Hello everybody. I think I usually say, hey guys, we gotta mix this up. I gotta tell you, this videoing thing is weird. I don't know how people talk on YouTube all the time, this new thing that my kids always tell me about where they're following people's channels. I don't understand staring at yourself. I don't get it. This is weird, but hopefully you're finding these helpful. Hopefully you're replaying them if you need to. I know it's me and it's probably a little bit annoying, but this is the best we can do. So LT2, it should be in the books by now. Okay, you should have gotten hopefully a 4 or 5 on the inverse square law, and as long as you wrote those steps down, I gotta believe you're all right. Today's stuff, you need a few things again. Okay, obviously formula sheet again. Make sure you have the practice problems. And I know I didn't mention it, calculator, so you probably paused it and scowled and yelled, but you had to get a calculator yesterday and today as well. All right, so for this math stuff. I'm going to give you a minute. I would assume that the video is probably getting paused right now. And here we go. All right, universal gravitation. I don't know that it's Wednesday anymore. All right, so I don't know if this is day 3, if this client had to bump things back, or if you guys are keeping up. But when you first look at this, it's probably a little intimidating. But you also looked at something back in the electricity unit that might have looked intimidating too, and most of you nailed it. So just like for the last target for inverse square law, we're going to put some steps on this formula sheet, so don't just go, I don't feel like getting it out. Okay, this is your cheat sheet. If you follow the steps, you're going to be all right. Okay, you guys are fortunate to have a math teacher in front of you, and I'm sure she can help with entering things and rounding and all that scary stuff. All right, I'm sure that's easy for her. Okay, tough for me, probably easy for her. So, what I'm going to do is give you a quick second to get this written down and to think about this. It's universal gravitation. I'm not going to put the date just because I don't know what day you're actually watching this. But infer, remember, like draw conclusions. SAT loves to say infer, all right? What can you infer about that equation right there? And I want you to think, if you remember, that this was Coulomb's law. You don't need to write this guy down. But if this is Coulomb's law for electricity, you probably remember that this was an electrical force. And since this is universal gravitation, I bet you can figure out what type of force we're talking about now. All right, so hopefully you can make the leap that we're talking about a gravitational force. When we did electricity, this was a constant. Okay, and it was a big number. It was 9 times 10 to the 9th. That was the constant. This is also a constant, but this one is a small number, 6.67 times 10 to the negative 11th. And you might be calling bullcrap on that because, like, no, Lance, that's a big number. Remember, if you write it out, it's a decimal. It's 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6, 7. In the grand scheme of things, it's a puny number. It's not what you want in your bank account, all right? That's not what you want. Pick K, and then remember your favorite science teacher, all right? So if you look through here, M1, M2, we've been using M for mass forever, so I bet you that you can figure out that that's 2 objects, and if you are conscious for LT2, you also know that D is the separation distance. All right, so we know some things about this. The concept today is just building on the distance part that we talked about yesterday. The farther you get apart, the weaker the force, and then bringing in the masses from target 1, where we figured out bigger mass, bigger weight, bigger force. All right, so technically, on your pink sheet, on your tracker sheet, it says you can calculate force, mass, or distance using the law of universal gravitation. I've got a confession to make. I gave up on mass and distance. All you have to be able to do is calculate force using that law. All right, so all that happens, it's going to feel like math class. I'm going to give you some numbers, and you've got to do the plug and chug from the old math textbooks. All right, you just got to be able to put them in correctly. So I will try to show you on my calculator. Don't use your phone calculators, all right? That's not the calculators you're going to use at testing stations. So make sure you find the motivation to get an actual calculator. And we are off and running. So the law of universal gravitation. That's a V. Okay, the law of universal gravitation. This word universal, I bet you know what it is, what it means. I think you know it doesn't just mean in room 106, or just mean at Shepherd High School, or just mean Isabella County. Everywhere. Okay, universal means everywhere we know to exist. So not just the earth even. Okay, the universe. Where's that end? Who knows? Okay, this is what we know to be true. So when we look at this force of gravity, we have this big capital G. It's called the gravitation constant. You already have the number for it up top. If you didn't write this down for some reason, make sure you have that number recorded. On your formula sheet, what I learned over time is that even though the law isn't written with this multiply, that's supposed to be multiply sign, people need it. A lot of people need it. So on your formula sheet, I separated this out a little bit. I'll explain the color stuff later. But it is going to be the last thing you do. So the first thing you do is worry about all this stuff. Then we worry about the constant. But don't forget about the constant, because you will be so close to being right, and then boom, you aren't. All right, so don't forget about it. But that's why I put the multiplication like this. Then we have m1, m2, d squared. So make sure I'm moving this around right. m1 is mass 1. We say mass number 1. It could be the Earth. It could be an asteroid. It could be a plate in the weight room. Like, it could be anything that has mass. All right, so mass 1. Therefore, you're smart folks. I know that you know mass 2 is just object number 2, or mass number 2. And from yesterday, we know D is the separation distance. There's two common mistakes with this learning target. One is, for whatever reason, we discriminate against that squared. We forget about it. So don't forget about the inverse square law. That's why I broke that up. And then big G. For some reason, we forget big G's, okay? All right, so we got our separation distances. Question for you to ponder. All right, question for you, and I don't like not being able to see your little faces to pick on you about this. But if we said this big G is 6.67 times 10 to the negative 11th, it's got units. You don't want to see them. They're weird for this, so I just left the units off. Does that mean gravity is a weak force or a strong force? So I'm going to do a little fill in the blank. Okay, so gravity is a blank force. Think back to electricity. Think about what you know about electricity. Think about that Tesla coil where we made fire. All right, Darren, okay, where we made fire. This number, remember, this is good for the bank account. So a 9 with 9 zeros. Whoops, apparently I forgot my comma rules here. But that multiplied by this made electricity strong. And we know that. Just a little ridiculous static shock from a doorknob can hurt. All right, so we know that electricity is a strong force. So here, if we're getting whatever our answer is from all this stuff, but then multiplying it by this, that little dinky number up there, that makes gravity a weak force. I always tell a story at this point because I've been teaching 50 years, not quite 50, but I won't use everything in video because then it would be in video and I'd get in trouble. But you know, if you got a crush on somebody and you learn about this gravity stuff, and you know, you're tootling down the hall, and you're like, oh, our two masses are attracted, and you go grab this person and claim, gravity did this. You can't do that, because gravity's weak. All right, gravity's weak with this because of that number. And the PG version of that joke is just no good, all right? But just remember, you're not going to feel the pull of gravity unless one object is huge. And we're not talking Lens after the holidays huge, all right? We're talking like you got to be a planet. You got to be an asteroid. You've got to be that big where you have your own gravitational field almost to actually feel the pull of gravity. You and your table partner are gravitationally attracted. You're gravitationally attracted to everybody in this room. It's creepy, but it's true, all right? But don't use it as a pickup line. It's not going to work because gravity is really, really weak. All right, with that said, next, we're not going to put the problems in here, okay? They're going to go on these practice sheets. So it may be a smart thing in the absence of myself to not recycle these immediately after completing them, in case you have to do a redo, that sort of thing. Hopefully you would go back through the video. I can hope, all right, if you do struggle with one of these learning targets. But make sure you've got your name on there. And the way the learning target will work is I will have just a list of numbers. Okay, you'll see a list of numbers. Now there's one thing missing from here, and it'll be missing on the actual learning target too, is the value for gravity. But you'll take your formula sheet up to that station, okay, because it's your cheat sheet, and you will always know the force of gravity, okay? And this isn't just on Earth, this is anywhere. It's the gravitation constant, universal, stays the same. Here's I'm gonna have to flip back and forth. It's not gonna be perfect, but I have it highlighted in yellow, which looks a little green. This step, where you multiply the masses together, that is the first step. All right, that is first step. So write that down, that is your first step. So we're working on number 1 right now. We'll do 2 of them together, and then you and Miss Klein will do the rest of them. So M1, M2, I'm gonna go 30 multiplied by 40. Just leave it. You do not need to write down intermediate steps. Just like in Coulomb's law, you did not have to write a single thing down. You just had the answer on your screen at some point. So that is step 1, which is mass 1 multiplied by mass 2. Answer is 1200. Second step is to take that answer you've got and divide it by the distance squared. Remember, squared. Square law, don't forget the squared part. So our distance in problem 1 is 525. So I've got the 1200 on the screen, divided by 525, remember Miss Narker says, caret 2. 525 caret 2, hit enter, whatever, big old ugly number, doesn't matter. Okay, you're gonna get really small answers here. So we move this aside for a second. The last step is to take whatever you get, whatever's on your screen right now, and you multiply it by the gravitation constant. Okay. Third step. This is where, if Ms. Klein needs to help you out possibly, remember how to enter this scientific notation. So I've got this big old answer from step 2. Okay, big old answer. I'm going to go multiplied by 6.67. I don't know why I feel like my camera is changing colors right now. So times 6.67 times 10 caret negative 11. So 6.67 times 10 caret. Remember, this is the negative down here, not subtract. This, not that. Hit enter. All right. Hopefully you can see what we've got here. Ooh, zooming right in on you. All right. So 2.9, a whole bunch of stuff, and then times 10 to the negative 13th. So what you might think of as your answer is it'll say round to the 10th, which if it's in scientific notation means leave the 0.9, and then it's times 10 to the negative 13th. But Moodle doesn't talk in that language. So remember, when you enter it into the screen, into the answer box at the target station, it's 2.9, then the letter E. Uppercase, lowercase, doesn't matter. Negative 13. So 2.9, the letter E, then the minus or the dash key, 13 is how you enter that. So I've had people in the past that have put on their formula sheet that E, whoa, that's one messed up E. E replaces the times 10 caret. Okay, that's what the letter E replaces in Moodle, is the times 10 and the caret. You may not need to do that. If you don't need to do that, that is fantastic. I'm going to go through number 2, and then I'm going to leave you here. So number 2, I'm just going to follow the steps on that formula sheet. I'm not going to flash it here in front of you. I'm going to zoom in just a little bit. Oh, I don't know what that button did. All right. Mass 1 times mass 2. That's the first step. So it's 50 multiplied by 300,000. Hit enter. No need to write it down. We've got enter. Next step. I hope you guys don't see the little sunshine on the video like I see the sunshine on my screen. It's creeping me out. All right. So we did this. Divide it by 675, but don't forget to square it because it's in the equation. So I go divide by 675 caret 2. Hit enter. Some big old number. Who cares? Third step, the last step, is to multiply it by big G. All right. So we multiply it by 6.67 times 10 caret. Nope, that's not caret. Times 10 caret negative 11. So 6.67 times 10 caret negative 11. And holy ugliness. If Moodle, if this was a problem at the station, and it says to round to the 10th, and if you rounded to that, obviously it's not right, okay? The reason I did that is some people like to convert into scientific notation. So it would be 2 times 10 caret blah, blah, blah. But what I've figured out is most people just want to type it in like this. You remember this, I would think, from when we did Coulomb's law. Some people just don't want to convert anything to scientific notation. That's fine. So just type it into the Moodle screen exactly like that. You don't need this 0 if you don't want to leave it off. That's fine too. But you would just put a decimal and then 1, 2, 3, 4, 5, 6, 7, 8 zeros and a 2. So it would be 0.1, 2, 3, 4, 5, 6, 7, 8, and then a 2. And you would just ignore the please round to the nearest 10th thing. All right, so remember your steps. Okay, just go slow. Make sure you type everything in correctly. You don't forget the squared. Ask Miss Klein if the negative 11 thing is getting in your head, all right, or how to enter it. Remember, if the answer, just for fun, if the answer is 6.8 times 10 to the negative third, okay, let's say you get that, you would just type into Moodle 6.8, letter E, negative 3. All right, good luck. You'll complete the gizmo before you do this target. So you will complete the gizmo, the fancier gizmo, before you complete this target. Good luck.